set, linked has set, and a sorted one I would like to tell you, that is tree set. Okay, as tree set is not a direct child to set, but it is coming from sorted set interface, as sorted set is a child to set again. So let us discuss about has set, linked has set, and tree set. So let me give you a brief what here itself. Has set, which, as all the set classes will not allow duplicates, that is common point for all the sets. So which will not follow insertion order. In what way you are inserting? So it will not ensure that that order will be the same. So while storing the values also. Okay. So as it is going to be a little bit different. So linker has set, which will follow insertion order. Tree set, by default it is in sorted order. That is by default. It happens by default in sorted order. And I already told you that duplicates, which will not be allowed by all of these three classes. So not only the duplicate values here, but duplicate. I mean, it will take one null value, one null value. So multiple null values will also not be encouraged in set classes. So all these three set classes will not take a null more than one. And I would like to tell you the tree set, by default, it will not take any nulls, sorted order, and no null values. Here, one null can be stored. Here also one null can be stored. So one null is a unique. Storing another null is going to be a duplicate. So let me open this. So creating a set class for all the sets. One class is enough. It from util. So I would like to store string. Okay, and I would like to discuss about has set here. So new has set. Okay, so two things I have imported, has set and set. Okay. Now, so I would just want to store the values. HS dot add, same add method. And if you want to go for add all, okay, so you have to use a method here. That is to array, I think, array dot. Let me show you how to store this, how to use this add all also. because not all the time, but sometimes you may need to have this for some situations where you want to store all values at a time. So there might be chances in your projects like storing entire array in single attempt, because again you're writing a loop for array, somewhat is going to be difficult for you. Just a second. So you're trying to store an entire array into the set or anything like list or map, whatever it is. Suppose you might be having an array list. Just wait, let me import the package, sorry, class. So already have an array list and you just want to store all the array list values again into the set. Here is my array list object. As I have apple, add grape, okay, these are the elements in my array list. Now I just want to transfer this array list to the set. So passing directly like this. Okay, so very easy. Now you're just converting entire array list into set. Array list into set. Here I need a method very badly actually to traverse them, because writing for each or for loop every time, it's not a good approach. Let me make a method, a generic method. Now I'm going to make here public void print collection. My method is print collection. So I'm going to pass here. See, now I need a parent that can support array list. I mean that should support the list as well as that should support the set, and that should support the map also. I need a parent here. So which one I can take means, let me take collection. Have to import this. It's a generic one. Okay, so in my for each loop, I can create this. Wait. Let me use list iterator or iterator also. Where is this iterator? Yeah, it's there. Iterator. Can you see this? So I'm able to call the iterator function using collection here. Now, what is the relation between the collection and iterator? So do you think the iterator function is a function of collection? Not exactly, but when I told you about this one, the collection hierarchy, what is the top of all the collection interfaces and classes? Who is the top of that means iterator, iterable. Okay, iterable is the interface. Let me show you the collection interface is going to extend the iterable. Yeah, can you see this iterable? From the iterable, there are some methods defined already in the iterable, that is iterator method. Already it is defined, and the for each loop is also there, which is exclusively works for collection objects. And can you see here as split iterator? So we are not using this one, but the most important method from this interface we have to learn is the iterator. Based on this iterator only, the list iterator was made, and it is also the child to iterable. But unfortunately, the collection is not going to extend the list iterator. But let me show you the list iterator also, then we can understand it. I think in my last class, we have a list iterator, I think. Yeah, this one. Let me search. So list iterator is there, but I don't think it is coming here. But let me search. So there is no suggestions for list, list. Can you see this? But there is a suggestion for iterator. Okay, so as iterator method is coming from the parent of collection, that is iterable, since it is accessible from almost all the collection things, and the set is child to collection. Now I'm going to store both set and list objects in the collection C. Through this, I'm going to iterate them and writing if while loop I dot has next system.out.println. Now we can display. Yeah. So I dot next method. So that's up now, and let me end this. Okay. Now, just by simply calling this method print collection. Okay. Let me make it as static so that an object is required from main to call it. First, I'm gonna display print collection AL, right? Execute. Okay, so we have got the output. Now let me print collection HS hash set. See, iterator is an interface which supports all the lists as well as sets, everything. But the list iterator is exclusively works only for the list objects, but not for set objects. For set objects, it won't work, list iterator, but iterator works for both. So what is the order at which one? Array list. This is the order at array list, and this is what the order at hash set. See, actually the lists by default they follow the insertions. Okay, in what order you have inserted, in the same way it maintains while storing the values also. But the hash set is somewhat different here, as it is not following the order of insertion. Actually, the first element in the list is apple, but the first element in the set was banana. Okay, and apple goes down after banana. And again, the grape and guava, they have also changed their places. Got it? So all this has happened because of the hash set doesn't maintain any insertion order. But to make an experiment, let me add a new element which is already exist in the list. That is a grape. I'm going to add once again to the list, and the same list I'm copying here also for the hash set, right? Now let me execute this. So while executing, these are the values from the list now. As a grape appeared 2 times in the list array list, but surprisingly in the hash set there was no one more grape. So I told you already the set objects by default they don't allow any duplicates. Okay. So what if there are multiple nulls I have in my list? List allows duplicates, right? So it accepts any number of null values. But the same thing which won't work for hash set. Let me show you this. See, can you see there is a null, one null is there, but not multiple nulls. So here are the multiple nulls over here, but here there is only one null value. So that means the set will take one null value and it will consider it as a unique thing. So all the values are unique ones only here and no duplicate ones are allowed. So that is the advantage of using hash set. Got it? Now let me create linked hash set now, new LHS dot add all. I would like to add all at a time. Let me send the same thing, or you can send HS, whatever it is. Either you can send the hash set which we have created before this one, and this one. Okay, so to the add all method, you have to send the collection object, and the collection object is any kind of object. If it is a list object, if it is a set, whatever it is, it takes. Got it? Now in the print collection, let me send my LHS linked hash set. Yeah. Now it maintains insertion order, right? So in the list, actually, the first element was apple, grape, banana, guava, and this is repeated and one null value. In the same way, you have unique values only, and it maintains insertion order, but insertion order is different for the hash set, and this is same for linked hash set. It maintains insertion order here in the linked hash set. Okay. Now for tree set, wait. Set of string. This is really a very good class, tree set, because it automatically sort your string values and everything. Everything is going to be sorted automatically. Even if it is string also, it will sort without writing a single piece of logic. Let me show you that magic. Tree set. Wait. Actually, before printing, we have to store all the values. Add all the values. TS dot add all. To the add all, you can send LHS or AL is fine. When we are sending AL, you'll be getting some exception. Let me show you that exception. See, there is an exception actually here. Null pointer. I told you already, no null values are acceptable for tree. At which line the error has occurred? 44. Yeah, this one. In this line. While adding items to the tree set, while adding the items, you are getting a null pointer exception, as the array list already contains a null. Yeah. So that's why you have to avoid null values while inserting into the tree set. Okay, just keep in mind to avoid the nulls while inserting to tree set. So that is the default behavior of trees. Trees won't take null values. Now see the output. Yeah, first apple, then banana, then grape and guava. This is sorting order. First APP, next B, G, G. Both are same. And what is the next alphabet of in the G, which is R, which is R is less than U. So by default, it's sorted in ascending order. R is less than the U. The ASCII value of R is less than the ASCII value of U. That's why it has sorted grape at the first and guava at the last, at the next. Okay, so this is in sorted order. By default, it is sorted. No need to write any logic. So that's about tree set gains. Tree set actually it has sorted set functionality. Let me show you that. Abstract. Just a second. Not this. Can you see this sorted set? So the tree set actually it implements a navigable set. Navigable set extends the sorted set. Okay, in the sorted set there is a function comparator, very powerful function. You can also override this function. You can implement on your own also for your list objects. So you may ask questions, sir, how can I sort my list? Okay, so as there is no predefined way to sort the lists, we have to write the comparator on your own and comparable also on your own for sorting your list objects. If you want to sort your set objects, no need to write any additional logic. You can just go ahead with tree set. But still, if your collection object is going to be holding the nulls and that should be sorted, so we cannot sort the nulls first of all. So as with comparator function, this function is going to compare two strings and two values. So while comparing the values, the null values are not at all acceptable. So before going for comparator or comparable, you should avoid the nulls. With null, what you can do with nulls? So nothing, right? So better to avoid the nulls for comparing. So this is what the behavior of tree set, how it is getting the sorted behavior from the sorted set interface. Okay, so this is all about the set. Very easy, not at all difficult. And this is same iterator. Now let's jump to the last thing. I mean the last interface for collection, that is maps. Maps are somewhat different. Yeah. So in the main, so there are multiple ways also for iterating the maps. Let me create my first map. Yes. Now, what you're thinking? What are these K and V? I told you in the generic naming conventions, K represents a key, V represents a value. So exactly the map object stores two values. I mean a pair of value. A pair of value contains a key and a value. The key should be always unique, but value can be duplicated. Okay. So what type of keys you would like to can I say integer? And what type of values you would like to accept? Can I say string? Okay. From this map, so it takes a pair of value that is key and value. And hash map is a first class we have to know. So same thing, which will not follow insertion. Insertion order will not be maintained. And linked hash map, if you learn one class, rest of the things are very relevant. So they're going to be very similarity. There are a lot of similarity between the classes and the functions here. So which will follow insertion order. And the tree map by default sorted order according to keys, but not according to values, but according to keys it will sort the things. And the basic things about map, key always should be unique. Okay, duplicates are not allowed. Next, value can be duplicated. And one null key will be accepted, and any null values can be accepted. Okay, as a null key, only one key you can insert, because key should be unique. Duplicates are not allowed, right? And for values, you can have any number of null values, you can duplicate the values. There is no issues with values in the maps, but the only concern you have to take care about the keys. You should be very careful, because they are going to be the identifiers, unique identifiers for your values. And the map now, first map is hash map. So this is the hash map. Can I take the same? No, I can't take the same actually here to here. I have to go on my own. So hm dot, the method is put. If you already have a map, and if you want to copy that map to this current map, you can use put all. Okay, so if you don't have already a map, then you have to create the first one on your own. Okay, so now my key is 3, and the text was 3. This is the first element I'm pushing to the map. 1, 1. hm dot put 5, 5. Next hm dot put. So one null, giving one null key, and just a dummy. hm dot put off. Okay, 6. Let it be the value as null. Oh, comma, it should not be comma here. Okay, so these are the elements for my hash map. Now how to iterate this? There are 2 ways. Actually, you can get it again back to the set, and you can iterate through iterator. That's the one way. And another way is to using entry set. Okay, so entry set in the sense, actually map is an let me open the map interface. I want to show you there is an inner interface, I mean nested interface, which is available here. I want to show you that. Yeah, can you see? So map.entry. So using entry interface and using entry set, you can iterate your maps. Okay, so you may ask questions, so why do I want to export it to again back to the set? Because the set has a feature that it will take only the unique values. It will take only the unique values. Whenever you want to have your values to be unique in your data structure, okay, as almost all the map objects supports duplicate values, but the keys can be unique, but values cannot be unique for your maps. But still you want to maintain that using map, you have to get it again back to the set. You can check it out on the set and you can process it while iterating them. Okay, otherwise you can just go ahead with your entry. This is the entry object. Okay, so please do remember this method, the put method, this one. And for put all method works for next map, because the same values I'm going to take it again for the linked hash map. So we can check it out whether if it is working, the put all method is working with all the objects at a time or not. We can check over there. Let me write the first iteration procedure for each. I told you the entry is a nested interface of map interface, which is a part of map. So you can access entry with entry is a sub means nested one. The nested one can be accessed with outer one. So map is the outer and entry is the inner. So you have string. Sorry. You have integer keys and string values. Just a second, I'm getting it. And strings as values, string as values. Okay, so an integer key and a string value, which is going to be same as like a hash map configuration. Okay, so like hash map integration has this kind of generic procedure, and the same procedure I'm following for my entry because I want to display them, right? Okay, now here you can use a temporary variable and hash map dot, you can call entry set now. So the entry set will return all the objects to the temporary variable, and using the temporary variable you can access things. One is the key and another is the value. This out, key temp dot get key, this one get key. Okay, and another one is, see, why to display the values. Okay, let it be. Get value. So this is the way, first way. Okay, let me take it to a method here. Public void print map. Let it be a map object, map m. M dot entry set. What happened here? Cannot convert from element type to map. Okay, got it. Just a second. Actually, it returns only the map, but it is not taking. Here there is no issue, but the same thing is going to be a problem here. So something happening in the back end because of the generic type. Okay. There is no issue because of the generic problem. So that's the concept of generic. Basically, it checks a type at the compile time itself, as generic types cannot be accepted here. But still, how can I make it? Okay. Then I think I should make my method as generic method. So this is what the generic method. Okay. So don't think too much, as I have some little bit experience on Java. That's why I'm making all these things. Okay. So this changes. Whenever error occurs, immediately I'm responding on that because I can understand the problem very easily based on the experience. But if you can practice a lot, you can also get the same thing. You can do much better than me. I hope so. So I've just made my method as generic method because see the problem is without generic, making it as generic, we have observed already, it is not taking k and v. So the compiler don't know what is k and what is v. It might be thinking about something different. So if there is any k type or v type like that, but I would like to tell the compiler it is a generic type. If it is a generic type, that method should be a generic method. How a method can be generic method means by identifying with the conventions, naming conventions. In the brackets, you have to mention the naming convention like this. Now your set works. Yeah, I'm sorry. Your print map works now. Yeah, I'm done here. No. Yeah. So this breaker is for print map. Let me call print map. What happened? Oh, I forgot to make it a static. So print map, which map? HM, the hash map. Display now. Okay. So null dummy 1 1 3 3 5 5 6 6 null. Okay. So is there an insertion order? Actually, the order of insertion is first 3, next 1, and then 5, and then dummy, and then the null. So this is the order of insertion, but it is not maintaining that order of insertion. See, first it is taking the null. It has changed my order. It's not like 3 1 5 6, okay, but it is like null 1 3 5 6. The order is completely different. Now I'm going to create integer comma string linked hash map is equal to new linked hash map. Now we can call the put all. LHM dot put all. Okay, put all. Let me send my hash map hm object. Call print map LHM. It maintains insertion order. Okay, the linked hash map maintains the insertion order. Oh, what is a problem? Still, it's not maintaining the insertion order. Okay, so let me copy. So if you can copy these values, I can paste it over here. It will be like that same, because of it's all about I'm putting the same hash map things back into the LHM. So it has stored in that way. Hash map stores the values in that way, in an non-order way. Okay, it's not like insertion way, but it's a random way. In what order it stores, in the same order it's trying to put all the values. That's a problem actually here. But if you can copy and paste the values again for this thing, for linked hash map, easy. Now execute. Okay, so it maintains insertion order. So earlier it was like the order of storing the values of map, hash map, and we have just pushed the same hash map again for linked hash map. That's why it has given you that non-insertion order. Now it follows insertion order, right? And map, let me get you one more thing. LHM, tree map, TM is equal to new tree map. So it cannot push either neither hash map or not hash map or neither linked hash map, because both of them are having null values and null keys. I told you already that tree map follows the sorted thing. The sorted thing should not have any nulls. You have to go ahead with a different approach without nulls. Let me copy, and I'm going to remove the null things. Okay, let me change TM, TM. I think I haven't displayed this, right? So TM dot print map TM. This is a sorted one, 135. Actual order of insertion is 3 1 5, but the displayed thing is 135. By default it will sort the case. Okay, and another way of displaying the maps, that is through set actually. So what you have to do for that is you have to take a set object. A set object is required. S is equal to which one you want to display. Okay, let me take hash map hm dot entry set. Okay, the entry set returns all the things to the S. From there you can display now using the set object, you can call the iterator now. The iterator can get you the things, both key and value. But you have to take care one more thing. You have to do some extra step over here. Iterator I is equal to s dot iterator. We have to call this now. I think I haven't imported this one. Now, as usual, while loop, go ahead with while I dot has next, and you have to convert again back to the entry object. See, every object of the set is going to be an entry object. So map dot entry temp is equal to I dot not I actually here, because it is an object, as next is not a generic method, so we have to convert it. We have to take care about this. Okay, let me call the next, and I'll typecast it explicitly. This is typecasting. Explicit typecasting is required for this. Yeah, now it works without any issues. Okay, now I'm going to display get key, get value. Like this. Execute now. So can you say this now? So this is the map I'm going to display by using set. So first of all, I have converted it to set, because earlier there was no this this is actually very old approach. Before for each, actually for each is a new one actually introduced in the Java 1.5. Earlier, Java 1.6 actually, not in 1.5. In 1.5 also there is no for each loops, but in 1.5 the collection framework has been introduced. So at the time of collection framework have introduced, every map is going to be iterated by converting first into the set, then calling the iterator, and again getting it back to the entry object. If you could able to access the entry object directly, why should I go for the set now? But still there are some advantages. If you want to get unique elements, you can just convert into set. If you want to get the duplicates, no need to convert into the set. Okay. Okay, so that's all. So that is all about the collection framework, and the next class we'll discuss about two important interfaces, comparator and comparable. I would like to discuss with you. Okay, sure. So that's all for today. Have a nice day. See you. Bye bye.